Good morning, good afternoon, and good evening. Thank you for joining Daniel, Powell, and I as we go through PLM in the public cloud and why and how. Today, we're honored to be with you on behalf of our global resources at Transition Technologies. We feel this is going to be a great session for you. And LiveWorks is always a date in the calendar that I look forward to immerse myself in technologies and rub elbows with some of the world's best technology experts. Unfortunately, we can't do that, but I would like to commend PTC for putting on these remote sessions and the efforts they've put forward. So let's get started. But first, a word from our sponsor. Now, I understand we've broke every rule in presenting by putting this messy slide up, but due to Transition Technologies global resources, we built a business that spans across many technical competencies and also spans across many verticals, as you can see below. But today we're going to talk about just the cloud and our experiences with a specific customer and some key takeaways for you to think about if you're ever considering moving to the cloud. With that, Daniel and Powell, go ahead.
Thank you, Nate. We are here to talk about setting up a PLM system in the cloud. Now, the value of the cloud is not a secret for a number of years now. It's been talked about, dissected in a number of ways. Most of what you're seeing right now should not come as any surprise to you. Among the most often raised points when talking about the value the cloud brings are the flexibility, which allows your organization to choose technologies and resources and scale them appropriately to your current needs. Efficiency, driven by the ability to tap into almost unlimited computing power and storage whenever you need it. At the same time, you only pay for what you're actually using. So there's a lot of possibility to eliminate costs, which were usually related to on-premise servers. Reliability is also worth mentioning. Thanks to the cloud's distributed model of data centers placed around the globe, you can be sure that even in cases such severe as natural disasters, your organization's data is actually still secure and available to your employees worldwide. Thanks to eliminating overhead related to infrastructure management and enabling automation in setting up systems, organizations can also leverage the cloud to decrease the times needed to develop and deploy new solutions, thus decreasing their time to market. What's often raised as a point of concern regarding public cloud is its security. However, security is actually one of the cloud's biggest strengths. Not only are all major providers compliant with various requirements and regulations, but they invest heavily into ensuring that the highest standards are met and exceeded. I don't know very many organizations which invest such vast amounts of money into security of their solutions as Amazon, Microsoft, Google, and other major cloud providers are. I'm sure you've heard about the JEDI program of the US Department of Defense. If they are comfortable with large-scale use of the public cloud, then any organization should be as well. However, we're not here to talk about the cloud in general. What we would like to do is share a story, a true story of one of our customers, to show you how the cloud has transformed their PLM system and thus their business. So once upon a time in a land far, far away, or to be more precise, in the middle of 2018 in Central Europe, a large organization, an automotive supplier employing over 10,000 people worldwide, was using Windchill PLM in a software as a service model. They used it for document management and change management at that time, but they were hoping to increase that scope to cover BOM management, CAD management, and various other modules. However, as they stood at that time, it wasn't really possible. So SaaS provision environments come with a number of benefits, among which you don't have to care about the infrastructure underlying the solution. You don't need to think about upgrades and the likes. However, SaaS users don't have complete control over the infrastructure and the environments they're running. So anytime that customer wanted to make any changes into any of their environments or requested new environments, what they had to do was open up a ticket within the support system of their current SaaS vendor and wait for its resolution. Now, all will be fine if not for one fact. These resolutions often took days to happen, sometimes even weeks. When an organization is looking to developing its PLM solution, such delays are problematic to say the least. They came to a conclusion that they might not necessarily need software as a service. They wanted to have full control of their entire infrastructure, allowing them to modify their environments and spin up new ones as needed. But at the same time, they got so used to the comfort of automation, they didn't want to do all these processes manually. They expected state-of-the-art automation to simplify on infrastructure management, system maintenance, and change management. With their current cloud provider, it was not really possible. So you can imagine that they might not necessarily be happy with that particular vendor. So they came to us, shared these problems, and asked us whether we could provide any solutions. We sat together with them and we devised 3 interdependent areas, tackling which should resolve most, if not all, of the issues this organization had with the PLM system. The first of these areas was automating their infrastructure setup. So the state we had was that any change in the system, any modification of an existing environment or creating a new one, unless it was a system down event, required opening a ticket and waiting for someone to address and resolve it. This might have taken days, in worst cases, weeks. And that's because a lot of work had to be done manually by system administrators on the SaaS provider's end.
Yes, and about manual work from the system administrator, that point was very important also for us, because after the delivery phase, our team was also responsible for a support and maintenance of the infrastructure. So usually when someone is opening a ticket and requests a new environment, like dev environment or test environment, there's some additional manual work at the end, which is, for example, installing the application, but also additional configurations or installing required build if the customer has some kind of customizations they are using on the Windchill system. That might take a couple of days to deliver. And on our side, we wanted to eliminate that manual work on our side in order to deliver faster to our customer and also avoid additional and easily repeatable and easy to automate work on our side.
Together, we have created a process, a detailed process of how would we manage the infrastructure and the solutions that were deployed on top of it. Now, if you want to specifically focus on the bottom right corner of this graph, now I'm obviously just kidding. This process is complicated and it would take much longer than the 30 or so minutes we have today to get through all of it. But what we will do is give you an overview and a starting point and a couple of guidelines of how to achieve that level of automation and maturity of your PLM solution based in the public cloud.
Yes, and in order to achieve that, we had to create some generic templates of Windchill application and Ingress application So in the future, we don't need to do this manual work I already mentioned before. So first step to achieve that is to prepare some kind of golden image of your application with out-of-the-box settings, with proper vault and database configuration, some kind of OS hardening, anything that you require on every single environment, from test environment and dev environment to production and QA. So we created such environment, and we created a baseline snapshot, which will be used for all environments in the future. Next step was to use, in our case, we use PDC rehost utility, because this tool does exactly what we wanted. So having one environment, we can rehost this environment to multiple versions of such basic configuration. So we could create different stages like dev, test, QA, prod, using the same baseline. At the end, we just added on top some DevOps automation and automatic scripts through Bash or PowerShell if it's a Windows OS system. Thanks to that, we can diverse from one golden image, which is our basic baseline, to different configurations with sometimes different builds. But in the end, our goal was to eliminate inconsistency between our stages. And probably every single administrator on your side or with your IT department can create such similar automation scripts. That's not a very hard work, but this definitely required if you want to achieve a DevOps state, which we were planning to achieve, or PowerShell if it's a Windows OS system. Thanks to that, we can diverse from one golden image, which is our basic baseline, to different configurations with sometimes different builds. But in the end, our goal was to eliminate inconsistency between our stages. And probably every single administrator on your side or with your IT department can create such similar automation scripts. That's not a very hard work, but this definitely required if you want to achieve a DevOps state, which we were planning to achieve. Of course, we had to use multiple services available with the current cloud vendors. In our case, we are using AWS or Azure to host the infrastructure required for Windchill and ThingWorks. So first step was to describe our infrastructure in order to make it easily reproducible and to avoid human errors in the future. So we use CloudFormation for that on AWS, or ARM templates in case of Azure. Of course, we had to use, like everyone else, virtual machines, but we didn't want to create our own databases on those virtual machines, so we used platform as a service from the cloud vendors. Additionally, we were using CloudWatch and Azure Monitor to basically have a close eye on our infrastructure to see what's going on with our environments. S3, AWS, and Azure Storage for keeping, for example, logs, but not only, also the baselines, the snapshot. It's an easy way to, and very cost-effective way to keep your data in the cloud. For our DevOps automation, for DevOps tooling, we also used container services, which are ACS and ECS, depending on which cloud vendor you will use. Also, the serverless solutions are like Lambda or Azure Functions, because it's really easy and cost-effective way of automation in the cloud, in the public clouds like AWS or Azure.
So where we got to was in a situation where the customer needed to create a new environment for development purposes or otherwise. The process now started by sending an email to the administrator to create such an environment with just a few simple inputs like the environment's name, requested resources, etc. This usually was no longer than a couple of lines in an email. So this administrator took that information, input it into the system, did a single click, and went to grab coffee. So while he was drinking coffee, a couple of things were happening in the background. So first, configuration files were downloaded, launch scripts were executed, a new database and a new virtual machine were created, and that guy is still having coffee. Network was created and configured. Generic templates were used, and a rehost script was ran so that the newly spun up environment is compatible with the network configuration. That guy was still having coffee. Vaults in the administrative domain were automatically configured. XConf files and other configuration files were copied and deployed in the system. All required licenses were added. That guy's still having coffee. Finally, the latest build is being automatically deployed. All tags are set as done. And before that guy's coffee managed to get cold, we have a new environment spun up and running. So you might think, why pay that guy for the 15 to 30 minutes where he's been drinking coffee? But that is precisely the beauty of automation. Once set up properly, main jobs of a system administrator is to oversee whether the process is executing properly and react only if needed.
And in order to achieve such a level of automation, in order to achieve DevOps state, which was our goal from the beginning, we of course used infrastructure as a code approach, and we described the whole infrastructure as a code. We keep it in the repository like a normal code, so it's easy to share the information about the infrastructure. You have the full history of the changes of the infrastructure, so you can go back to the point when everything was fine. You can do some kind of experiments with your infrastructure, and everything is easy to manage, and it's easy to hand over such infrastructure to someone else if needed. That's the first step we had to do, because the next step requires such level of automation, because we wanted to have one single click button development creation, like Paul already described in the previous slide. And at the end, that was a requirement from our support team, that the infrastructure had to be reliable and highly available, and they didn't want to do it manually. So in this point, our infrastructure is self-healing. If we detect that something is going wrong with our cluster, and for example one of the nodes of the cluster is not responding, we'll spin up the new one, and this new node is automatically synchronized with the cluster, with the vaults, with the database. That doesn't require the administrator attention, because everything is automated in a proper way.
So Daniel, you've actually touched on a very important point here, and this brings us to the second area where we look for improvement, which is backups and disaster recovery. Now, you might not expect that things will go wrong. Nobody does. With the time that we're running this customer in the public cloud, we have not experienced any issues so far, but things will eventually go wrong. It's not a matter of if, it is a matter of when. And when that happens, nobody wants to be that guy who in the middle of a pandemic, a flood, fire, or whatever, has to drive to the server room and try to bring back to life a solution which died for whatever reason. So although you're actually building the environment expecting it to be available, be online, you need to always plan for failure. Every system will eventually fail. Take it for granted. What you want to is to be prepared. You want to minimize any recovery time so that in the best case, users are impacted to as low a degree as possible, hopefully even not noticing that the systems went down. Now, this is hard, but achievable. How? Through automation.
That's why we added a lot of system health checks, which are automatically checking the status of all our environments and instances. So we can always react on the situation when something is wrong with the environment. We can spin up a new environment. We are constantly monitoring our infrastructure. In our case, we're using PTC system monitor, but you can also use solutions like Datadog, or you can create your own solution. In our case, it's a mix of PTC system monitor, who's checking the production, if everything is fine, if performance is okay, or how the user experience is developing with our production. But also our additional checks, minor checks on the rest of the infrastructure, which can watch also for dev and test environments. And of course, we have to keep all the logs, because mainly this is a requirement from every IT department and every security guy you can imagine. And also it can help you in the future. If something goes wrong, you always have the logs safe and centralized and versioned. And we also create a backup of those logs. So even if something really goes wrong with the whole region, for example, you know that your logs are safe. As it was mentioned before, everything was described as a code. The whole infrastructure was kept as a code. That makes your backups easy to automate, and also you can create your disaster recovery scenario, and you can easily test it, because your whole infrastructure is reproducible in an easy way. That's why in our case, we are hosting our customer in North Virginia. And if something will go wrong, like, I don't know, some kind of natural disaster will happen, we can automatically spin off the new production system with the whole infrastructure in a different region. In our case, it's Ireland, and we know it's safe. And thanks to automation, we know it will work in a couple of hours, and all the systems will be back online, working properly. So our customers is safe in a case of emergency, even if it happens to the whole region.
So the homework you've done, creating the automation, creating all those scripts, starts to pay off immediately. Now, another area where it may pay off is one of the most important ones for many organizations, which is cost optimization. Because clouds are great, but let's be honest, that situation only is as far or as long as until the first invoice arrives. And you will not read it in any official reference papers. You will not read it in any official releases from any cloud vendor. But try approaching and discussing with Amazon's, Microsoft's guys responsible for their respective cloud services. And they will admit that transferring your infrastructure and your systems one-to-one to the cloud can be even 2 or 3 times more expensive in the long run than actually maintaining your own on-premise infrastructure. So by being smart in cloud management, in cloud infrastructure management, you can save a large amount, even 40 to 70% of the infrastructure cost. That makes cloud a lot more interesting and a lot more attractive cost-wise.
Okay, so one of the best reasons to use Spot. God damn it! Once again, one of the best reasons.
Wait.
What?
Start with saying what the hell is a Spot instance. So you might be interested in something called Spot instances. Spot instances are blah 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 blah, but they're not
I would
secure.
start with the best reason to invent in automation is to the option to use Spot instances, and then say what Spot instance is, and then you know. We'll see. Yeah, but I agree with
Perfect.
you in
So,
general, right? Okay. Ooh. Okay, so one of the best reasons to invest a lot of time into automation is the possibility of use spot instances. And spot instances is a little gambling on your side when you are saying that this is the amount you are going to pay for this instance, and if the price somehow will go higher than that, you will basically lose this instance. So you need to do assumption that you can lose this instance anytime without any specific reason. So without a proper automation, you cannot really use it, right? So the reason we invested a lot of time into automation was that we we wanted to use this cost optimization with spot instances, because discount is close to 80-90% per virtual machine, and that was the reason that we invested so much time. Thanks to that, we're able to even use development environment running on spot instances, because we are not afraid of losing such instance, because it will easily spin up again thanks to our automation. Another interesting point is to always be up to date with your cloud vendor, because from time to time there are new instances, new families of instances released, and usually they are cheaper than the previous version. So the sooner you will switch to new instances, then better for you and your budget. Another interesting case is something that we learn in a hard way with our reservation, because you always need to reserve resources, at least for your production system, in order to be sure that there are always compute power enough for your infrastructure, for your production to be running. But if you are using a specific OS system like Red Hat Enterprise or Windows, in our case it was Red Hat Enterprise, you need to be careful because then you cannot switch between families. So, for example, if you made a 3 years reservation upfront with general purpose instances, you cannot switch to memory optimized or CPU optimized. And that might be interesting option for you, because in Winchell case, this is a Java application, so memory optimized instances are very attractive for you. So please be careful with this one and make a decision, make a responsible decision. Okay. Oh, damn it, I forget about shutdown new unused resources. Excellent. Okay, so of course, you need to remember that with your on-demand plan, the instances, the environments, the virtual machines are very expensive, and you need to analyze and decide which environments are needed and what time, because probably your dev, test, or even QA environment is not needed 24/7. So we need to create some kind of scheduler in order to shut down unused resources, and that's exactly what we did for our customers.
So you might expect that all of this may be done manually, but as our customer, from our story, expected full control of the automation on their end, while not creating cloud proficient resources within their own organization, there are ways of simplifying that. What we did for that particular customer was create an application in ThingWorx, which we called Cloud Scheduler, that allowed, as you might have already guessed, scheduling startups and shutdown of certain instances they were running in the public cloud. As you might imagine, developers, development, test, and QA instances are not usually needed 24/7. In most cases, these environments are needed, say, 9 to 5, Monday through Friday, Besides that, if they would be kept running, the only thing they would do is generate cost. Now, in order to eliminate that, you would need to shut down all these resources. To do it manually, you might forget to do that. So that's why the tool we created allowed, yes, also manual on-demand creating and shutting down such instances, but also doing that according to schedule. So say 8:30 a.m. comes on Monday, a new development environment is spun up, the latest build is deployed on it, and the developers, when they start working at 9 a.m., they got the development environment ready, waiting for them. And when 5 p.m. comes, the development environment is automatically shut down, unless required otherwise by the development team, in which case it can be easily extended. So this allowed us and the customer to simply control the entire infrastructure, every environment they are running, which again boosted cost efficiency, ensuring that they only pay for what they're actually using and what they actually need at any given point in time. So that concludes the 3 areas where we found ways to optimize our customers' organization and their PLM systems in the cloud. Thank you very much, and over to you, Nate.
So our goal is to give you the why and the how to move to PLM in the cloud, or the cloud in general. This is not going to solve every issue that you have today. That's why leaning on our global resources and our cloud team, we believe is a valid choice for you. But today we want you to walk away with some key takeaways around what Pablo and Daniel went over around cost optimization. Not only getting rid of the unnecessary cost, but finding smarter ways to eliminate the pennies and the dimes that add up through going to the cloud. As well, the flexibility and shorter time to market that you can utilize by doing updates, upgrades, configuration changes within the cloud. And if you didn't hear it, you're going to hear it now. Automation can provide security and give you flexibility as well within your working teams. So that concludes our presentation for today. On behalf of Transition Technology and our global resources, I'd like to thank you for your time. Please provide us with feedback so we can improve this session. And if you want to reach out to Daniel, Powell, or myself, here's how you get a hold of us. Thanks for your time and have an awesome day.